Good evening, sir.
Hello everyone. Am I audible loud and clear to all of you?
Yes,
Good
sir.
evening.
Yeah, sir.
Good
Yes, sir.
evening all. I hope all of you are doing well. Okay, just 1 minute, we'll start the class. So as mentioned in the previous class, I told that I'll declare the topic that we're gonna start. So basic maths is pretty much over. Uh, Whenever it is required, I'll take some extra class to help you out with any topic. But more or less, you guys are now comfortable with whatever is required. So today, as I mentioned in the group, in physics one, you're already having mechanics going on. So that will be going as per plan. And in my track, I will start with a topic called heat and thermodynamics. But today we're gonna discuss heat and temperature. So it has nothing to do with mechanics, laws of motion, nothing. It's a totally different topic and a very important topic. I'll tell you, this topic is one of the most scoring topic of physics. If you get it, it's easy, it's very uh, gettable, and there is no complications. So we'll try to get in details. I'll try to make things easy for you guys. So before we start, now in maths, I was not getting opportunity to discuss the concept because it was more or less formula and the application for us. Now here it's proper physics topic. So let's discuss the concept and try to learn it, right? So guys, what is temperature? What you understand, will come to heat, but how we know temperature? Shri, you can unmute yourself better.
Yes, sir. So temperature is the degree of hotness or coldness of a body, and uh, heat generally flows from a body of high temperature to a body of lower temperature.
Correct. Totally agree with your definition because that is what we all learn in our class till class 10th. So totally fine. But actually, this definition itself, degree of hotness and coldness, right? It's a very relative thing. I'll tell you why. Uh, Something which is hot for us may be cold for some other place, or something which is cold for us may be hot for some other place. For example, we all know that temperature on the earth varies with different locations, right? So let's say someone is living in Serbia, which is a part of Europe or Siberia, let's say, where the temperature is in minus. For them, even 0 degree or 5 degree is a high temperature. But for us living in India, anything below 30 is a normal temperature and anything below 15 is a low temperature. Is this clear? So same temperature could be degree of hotness and coldness if we define. Same temperature could be hot for someone or maybe cold for someone, right? So that's why this definition works till class 10th, but in 11th and 12th, or especially for JE, it doesn't hold that much because of the flaw in the definition. I'm totally fine with your definition because that's what I have also learned when I was in class 10th. But all of you understand what is the problem here? When we say degree of hotness and coldness, we are trying to refer something. We are trying to create a reference point. And that reference point may varies from place to place, person to person. So let's try to decode the other way of defining temperature. Now we all know that it's the body temperature, right? So it's basically the temperature definition. We can say that it is the average kinetic energy of molecules, because it's the kinetic energy what's creating the thermal energy, right? It's the average kinetic energy of molecule of a body. Now, when you say average kinetic energy of molecule of a body, you can't take it for a relative point of view, because kinetic energy is absolute, right? So all of you, are you getting my point from where I have started this chapter? Is this clear to everyone?
Yes, sir.
That
Yes.
now onwards, we're going to define temperature as the average kinetic energy of molecule of a body. Higher the temperature, higher the average kinetic energy. Simple. As I already mentioned, what Shri answered was totally fine, but it will not work now. So we will try to contain ourselves with this definition. Now here comes the question. What Shri said, that body heat flows from higher temperature to lower temperature, is perfectly fine definition. If you have two bodies, it obviously, and they are identical, so obviously heat flows from higher temperature to lower temperature. But does only temperature, heat and temperature depends on each other, or it depends on other factors also? We have to see in this chapter.
Other factors.
Yes. So that's why we have to understand that not only temperature decides how the heat will flow, there are mass also, there are material also, right? These all things will dictate how and when this heat will flow. So we will say that heat flow from higher thermal energy body to lower thermal energy body. Heat flows from, I'll give you an example to make you understand what is the difference between higher temperature and higher thermal energy. I'll tell you one thing. Suppose you have a bucket of water. Okay. The water is at 20 degree and it's a full bucket full, let's say 20-liter bucket. And you have a glass of water. That glass of water is at 60 degree. When you mix glass of water in bucket, do you think the heat will flow from the water in glass to water in bucket? Or it will be other way around?
But it will be from water of glass to the water of bucket.
But beta, water of glass is how much?
So water of bucket to glass.
As I said, Gaurangi beta, our energy, heat energy, depends only on, not only on temperature, but it depends on mass. Okay. Now glass is anyway will be 100 ml, 200 ml, 300 ml, right? How much water you are having in the bucket? 20 liters. Now 20 liter of water will have more thermal energy as compared to 200 ml of water. Don't you agree? That's why when you
Yes.
mix a small amount of water in a bucket, it won't change its temperature. But the temperature of glass in the water will come down to the temperature of water in the bucket. Is my point clear to everyone? What I said here?
Yes, sir.
Yes, sir.
So there are two myths which I tried to remove. One was that this degree of hotness and coldness, and the other was that heat flows from higher temperature to lower temperature. When we say higher temperature to lower temperature, when we have two identical bodies, means their mass and material is same, then you can easily say that, okay, heat flows from higher temperature to lower temperature. But if we don't know about the other properties of the body like mass and material, we will always try to play safe and say heat always flow from higher thermal energy or higher thermal to lower thermal energy body. So there is a topic called calorimetry. In calorimetry, I will make you understand how heat flows how equilibrium achieved, what happened when we mix a ice with water, what happened when we mix ice with steam, how we calculate the final thermal energy or final temperature, everything we're gonna discuss in that particular topic. So this heat and thermodynamics, broadly, if I say, heat and thermodynamics is combined of 5 main topics. It's a big section. Okay, so in first, we will learn about temperature and thermal expansion. So temperature means temperature and temperature scale plus thermal expansion. What is thermal expansion? All of you understand. When we give heat, solid, liquid, gas, they expand. So that part we're gonna learn in the first chapter, first topic. Then comes, after thermal expansion comes calorimetry. In calorimetry, we're gonna learn about mixing of different bodies at different temperature and try to get the final temperature. Clear? So calorimetry will be our next topic. And once we are done with calorimetry, we will see the thermodynamics. There is thermodynamics in chemistry also, and there is thermodynamics in physics also. Laws of thermodynamics. After thermodynamics, we will see the mode of heat transfer, conduction, convection, radiation. And after that, at last, we're gonna take kinetic theory of gas, where we will see the molecules and their behavior with temperature and all. So this kinetic theory of gases is short form is KTG. So all in all, these are main topics which we're gonna cover in this particular section called heat and thermodynamics. Is this clear to everyone? Now let's come to temperature. So temperature we understood. Now how we gonna measure it? So answer is simple. Temperature is measured using temperature scale. Now, how many types of temperature scale do we know?
3.
Three.
Three types.
Celsius.
Degree,
Celsius and Fahrenheit.
Fahrenheit.
Celsius, Fahrenheit, and Kelvin.
Very good. These are the 3 main scales we use. Which one is standard scale or universal scale? Can anyone answer?
So Kelvin.
Kelvin scale.
Kelvin scale is a universal scale. Why not degrees Celsius and Fahrenheit?
Kelvin is the SI unit.
What? Yes, beta. Could you repeat it?
So is
Kelvin.
it because Kelvin is the SI unit of temperature?
No, that answer why Kelvin is SI unit is there in why the Kelvin scale is the standard scale. Both are related. So we're gonna see why Kelvin is taken as a standard absolute. Yeah. Someone want to answer?
Sir, Celsius is derived from Kelvin scale, which is the SI unit based for temperature.
Celsius is derived. You are talking about the equations.
Yes, sir.
Beta equation we can equate with any of the scales. I will teach you how to equate the equations of 2 different scales. My question is, we use Celsius in India, we use Fahrenheit in US or other Western countries, right? If you see their news channels and all, the temperature, the weather they forecast is temperature they forecast is in Fahrenheit. In India, we use degrees Celsius. Still, we say that, which all of you have answered, Kelvin is the standard scale. my question was why Kelvin? Why not degree Celsius? What is wrong with degree
Well,
Celsius?
maybe because the 0 degree Kelvin is considered absolute
it-
zero, and for Celsius it's minus 273. So maybe.
Okay,
Yeah, I
good.
was also thinking that I'm not sure, but is it because of the absolute zero where the motion, I forgot its absolute
It
zero when
ceases.
the molecular motion ceases. Is
Yeah,
it because
it's
of that?
something related to that.
Sir,
Correct.
the
Ah,
SI system is based on the absolute value. As Kelvin is not an absolute value, it is a derived scale from Kelvin. As Celsius is not an absolute value, it is derived from Kelvin. That's why we use Kelvin.
this is also one of the reason, beta. I will not dismiss it, but I would say the main reason why degree Celsius we don't take it is something related to what few of the girls has pointed out. It's the reference point. Okay. So what we're gonna see is what we're gonna try to learn is how we decide or how we design the scale. And while learning it, we'll try to identify the reasons why degree Celsius and Fahrenheit was not taken as the standard scale. But Bhavesh, what you are saying is not incorrect. It's correct, but there is more reasons for why we have not selected the Celsius scale. This is one of the reason what you have mentioned. Okay.
Yes, sir.
So let's take it. Okay. Let's take a scale here. So I'm taking what I'm doing is I'm taking right now, I'm not referring any Kelvin scale. I'm taking Fahrenheit, degree Celsius, and a unknown scale. So this is my Celsius scale. This is my Fahrenheit scale. Spelling wise, just and this is any unknown scale, which is not very famous. Let's take it as something called Riemann scale is there. Riemann scale. We'll take it like this. Okay. You can make a scale of your own. So Riemann scale, it's unknown because it's not that famous. That is the reason. Okay. All right. We want a scale. So we want reference points, right? The easiest reference point available for the scientists when we were designing the scale was melting point and boiling point. Celsius said, it's my scale, so I will take the melting point as what? Now keep your eye on the reference points, melting point. Okay. Celsius said, it's my scale, I will take it as 0. Right. And I will take the boiling point as what? All of you know?
100 degree
100 degrees
Yes,
Celsius.
100 degrees Celsius. So he decided that he'll take these 2 points as the reference point. Okay. So let's say he take body temperature and it comes out to be T. So we will use the unitary method to get the relation. Okay. Now, same body if measured on Fahrenheit, but Fahrenheit said, look what, I will not going to use the same scale because I want my scale to be unique. So I will use the same reference point. So the reference point on Fahrenheit scale and degree Celsius scale was same. But does the value was same? No. Fahrenheit said, I will take the melting point as 32 Fahrenheit. And I will take my boiling point as 212 Fahrenheit. Is this clear to everyone? So basically what Celsius did, what he divided the melting point and boiling point in 100 units. So tell me one thing, for a water to boil from melting to boiling, it will require same heat whether you use Fahrenheit or degree Celsius, what difference it will make? The heat required by water will be same. Yes or no?
Yes, sir.
It doesn't
Yes,
matter,
sir.
na?
Yes.
It doesn't matter. It's same as the length of your height doesn't depend on which scale you are using. The unit will change. So Celsius have divided melting to boiling in 100 units. Same melting to boiling, Fahrenheit has divided in how many units? 180. Okay, equal parts. Now, the same body whose temperature is T in degrees Celsius on Celsius scale has become T in Fahrenheit scale, or you can say this T1 and T2. Now, as I have taken one more scale, so let me give the values of Reaumur scale. So here Reaumur decided that he will take 0 as the melting point, but boiling point he will take 80 degree centigrade. Clear? Now the same division he did in 80 parts. And again, here the T of unknown. Now guys, tell me the amount of heat required here, here, here is directly proportional to the rise in temperature. Is this correct or not?
Yes.
The amount of heat required to boil a water is directly proportional, or the amount of heat is directly proportional to rise in temperature. So can I say, first of all here, what is the rise in temperature? T1 degrees Celsius, and from where it has risen? 0 degrees Celsius, correct? And what was the number of divisions? 100 minus 0. In Fahrenheit scale, tell me what I should write, all of you. Should I write T Fahrenheit minus 32 divided by what is the per unit rise value, or what is the number of divisions?
212 minus 32 or 180.
180. And this unknown scale, what I should write? T of unknown scale minus 0 divided by
80.
And if I take, okay, so we'll have this. Is this relation clear to all of you? Everyone I'm talking here, which are present in this batch.
Yes, sir.
Guys, are
Yes.
we clear with this? All of you?
Yes, sir.
Good. So between Celsius and degree Fahrenheit.
Sir,
Yeah, Vijay.
can you please explain that relation, that ratio once again?
Yeah, sure, beta. Abhijay, for Celsius, how many parts we have divided
100.
between boiling to melting to boiling? 100 parts, right? And what is the rise? Rise is final temperature minus initial temperature, correct?
Yes, sir.
So this is rise per unit division. For Fahrenheit scale, what is the rise? Final temperature minus melting point divided by per unit division.
Yes, sir.
And for unknown scale, final temperature minus melting point divided by per unit division. This is how we're gonna relate any temperature scale. Clear now, beta?
Yes, sir. Yes.
Okay.
Sir,
So
so we are finding out rise per unit.
yeah, actually,
We are
per
dividing.
actually the divisions are not same now. So we have to take the unitary method. What we
Okay,
are
sir.
doing.
Yes.
Got it?
Yes.
Actually, per unit division is equivalent to 1 by 100 for on degree Celsius. And this is the number of, or this is a rise in temperature. So we have to equate it. So that's why we are using unitary method. And here between Fahrenheit and Celsius, what is the relation, final relation we are getting? T degrees Celsius upon 100 equals to T Fahrenheit minus 32 divided by 180. So obviously this will become 5, this will become 9. So what we are getting is Fahrenheit equals to 9 by 5 degrees Celsius plus 32. Okay, this relation is simple. All of you have understood it, I hope. So please note it down, this one. One important thing, for every 1 Fahrenheit rise in Fahrenheit scale, how much will be the rise in degree Celsius scale? Because the question will not come on this formula, trust me. At least in JEE mains or advanced, you will get question on this formula. Delta TF should be equals to what? It is 9/5 times of delta degree Celsius. Is this point clear to everyone?
Yes, sir.
This is
Yes.
change in temperature in Fahrenheit. And this is change in temperature on Celsius scale. So all of you, are we clear with this beta? Everyone?
Sir, how did you get this equation?
I will take, if I take Gorangi two temperatures on Fahrenheit, let's say T1 and T2. So T2 you will write, T2 in Fahrenheit you will write as what? T2 in Fahrenheit you will write T2 in degree Celsius plus 32, correct? And T1 you will write as what? T1 in degree Celsius plus 32, correct beta? Now what we want? Change, right? So when we want change, we will subtract the first equation with second equation.
Okay,
So-
okay, got it. Yeah, I
Got it now? Huh. And all of you, whatever I am writing, if it is not clear, just like Gorangi and Abhijay, feel free to ask. Don't hesitate. Because every time it's not necessary that everyone will be clear at what I'm writing. So this is how we got it. That's what I have written. Sorry, wait. 9/5. So we get 32 will get cancelled. 9/5. Okay. All right, guys. Here's my first question. Find T for which degree Celsius and degree Fahrenheit gives same value. Fine. Correct, beta Yash. Isabel correct, Konika correct. Dev correct, beta. And try to send the answer only to me. Dhruv correct. Abhijay, check your answer, beta. Shri correct. Grishma correct. So I think Bhavesh correct. This one is pretty easy, and I was expecting all of you to get the answer, and all of you got it. Arinjaya correct, beta. Aradhya correct. So here the answer is -40 degrees Celsius or -40 Fahrenheit. You'll get the same value. Simple, you'll just put the equation. Let's take both temperature as T. So this is what you will get. So simply you will solve it. You'll get 5T minus 90, and this will become, I think, 160. So minus 4T equals to 160. So T will be -40, either degree Celsius or -40 degree Fahrenheit. Okay, let's take another question. And I'm not going to give questions like conversion and all, because I know you guys are smart enough to do those questions by yourself. So here is my next question. A body temperature changes from 30 degree to 90 degrees Celsius. Find delta T Fahrenheit scale. Correct. Shri, Abhijay, Arinja, Bhavesh, Isabel, all of you got the correct answer. So the Konika beta, please check. So the answer is very simple. As I said, delta T in Fahrenheit is 9/5 times delta T in degree Celsius. So in degree Celsius, the change in temperature is 60. So it will be 108 Fahrenheit. Okay. So that is the answer, and all of you got it fine.
So shouldn't we add 32?
Sorry, beta. No, Aditya, actually here we have to get the change in temperature, right?
Oh yeah, sorry, 32.
No problem. Just be careful next time. Okay. My next question is, there is a faulty thermometer, or I can say a thermometer. Wait, let me just show the question to all of you. Wait, better. Is this 20.1 visible to all of you?
Yes,
Yes,
sir.
sir. Yes.
Okay, go for question number 3.
Done, sir.
Yeah, one second. Konika, Dev, Isabel, Manushri, correct. Bhavesh, beta, check your calculation. I think you missed 10, or you Dhruv, correct. Shri, correct, beta. Gaurangi, correct. Very good. Sariska, correct, beta. No, sorry, Sariska, please check your answer, beta. There is a small variation. So here, how you have to solve this is this faulty thermometer is given
Sir,
whose melt. Yeah, Bhavish,
what's the answer?
122.
Yes, sir, got it.
Okay. So here, beta, all of you, this faulty thermometer, you take it as unknown thermometer. We know how to relate it and with what temperature scale they want. They want with Fahrenheit. So what we're gonna do is, one sec. Temperature in Fahrenheit minus 32 divided by 180 equals to temperature in 40 degrees Celsius minus what was the melting point they have taken? 5. So we'll write melting point as 5. Between boiling point and melting point, 99 minus 5. Is this clear to everyone? Please give me a thumbs up for this relation if we are clear, all of you. Everyone, are we clear with this? How I have written it? Because this is the main thing. Okay. So the temperature on the faulty is 52. So we'll take 52. Arinja, please check 52 minus 5 upon this will be,
1 by
I
2.
think, 92. And F minus 32 upon 180. So 52, basically 1 by 2. This is 180. So obviously this will become 90 plus 32. So 90 plus 32 is this clear to everyone?
Yes.
Yeah, Arinja, correct, beta. All of you are clear with this? Okay. So now let me tell you about the main scale we have, that is Kelvin scale. Kelvin scale is also called absolute scale because some of the girls have already pointed out it. One of the reference point is absolute zero. Okay. So here let's talk about the reference point of the Kelvin scale. One absolute point is 0 Kelvin, where what is the meaning of 0 Kelvin means where the molecular motion ceases. It stops. Is it possible to achieve this temperature? No.
No, sir.
Absolute zero means nothing. Life is over. So zero, absolute zero or 0 Kelvin is not achievable, but this is one of the reference point, hypothetical reference point taken because this point can't change no matter what. And the other point which we have taken for the scale is called a very special point, is called triple point of water. Triple point of water. Have you guys heard about this triple point of water in chemistry?
No, sir.
If
No,
not,
sir.
then you will learn about this. Actually, triple point of water is where ice, liquid water, and steam coexist. together. It's a very special point and it's unique. It doesn't depend on pressure or any other factor. So triple point of water, it is taken as 273.16 Kelvin. Okay. So these are the two reference point we have. What is the difference are you seeing in the reference point of Kelvin scale versus reference point of Fahrenheit or degree Celsius? Because the question I asked, the answer lies there only. Yeah, Gorangi, you want to answer?
Sir, I just wanted to guess, is it that when we looked at the reference points for Celsius and Fahrenheit, we took the boiling and melting points of just water. But for Kelvin scale, we tend to look at the molecular movement. So the two reference points that we took was absolute zero, when molecular movement ceases to exist, and then we took the triple point of water.
Yes. Guys, do you all agree that melting point and boiling point depends on pressure? It changes with pressure.
Yes, sir.
Yes, sir.
And we know that all of you are aware that at high altitude, it's difficult to cook food, right? Because at high altitude, pressure decreases. So water boils a bit faster. So food doesn't get enough energy. So it's very difficult to cook, right? That's what the purpose of pressure cooker. It increases the pressure, which increases the boiling point, and that's how the food gets enough energy, heat energy. So basically, boiling point and melting point are not the absolute points. It is variable. It depends on pressure. Now, can we use a scale whose reference point changes with altitude or it changes with location as a universal scale?
No, sir.
This is the main reason why Celsius and Fahrenheit are not considered as the standard scale, because the reference point taken are not standard. They varies with pressure. So we can't take a scale which may give us different value in India or may give us different value, let's say in US. Okay, I'm not saying the variation will be very large, but in science, small variation is also a variation. Is this point clear to all of you?
So I
Yes,
It's a
sir.
understand the point of water, like how would we have steam in 0 degrees Celsius also?
sorry.
Then in this triple point of water, 273 Kelvin would be equal to 0 degrees Celsius. So how would we have steam in that?
273 Kelvin is 0 degree, beta. 0 degree is 273.15 Kelvin. This is 0 degree Celsius. Let me write the equation properly. Because what we have learned is 273 only. We don't put much attention on 15. Okay.
And like,
So
I want to ask, why would we have steam also present in this amount of temperature? Like steam is for 100 degrees Celsius.
that I will explain. If you want, I have to go in chemistry. Okay. So I'll take time out and I'll try to give the slides and all to explain the graph of condensation and melting and all those things of ice, right? So then you will understand how it coexists. Then the topic will divert to something else. But if you want, I'll take it in the next class. Okay, Vijay? Huh. So coming to this point, boiling point and melting point varies with pressure. That's why they are not the standard scale. Are we clear with this? Now let me write the Kelvin scale value. Actually, temperature in Kelvin is basically temperature of degree Celsius plus, sorry, 273.15. Now there is a question why we are using 273.15, why not 273.16? why this value is taken as 273.15, why not 273.16? And you have to figure that. Yeah,
I was just guessing that 273.16, all the three states are existing. But if
Hmm.
we have to take a standard, then we need to take only one state. So, like we have 0 degrees Celsius as 273.15 Kelvin, and 0 degrees Celsius is melting point of ice where steam will not exist.
Very good. What I have asked guys now, this is a NCERT question. All of you have NCERT. If you see this chapter and you open the exercise now, this is I think second or third question, but it's very important. Actually, I'll tell you what is the problem. We as a student, we think this is the relation, which is not wrong. 273, right? This is generally we use. We don't discuss much about this. And the JEE people know that student 90% or 95% student ignore this, not because they don't know it, because the teachers don't discuss it. So they are looking for these kind of questions where they can trap a student. So this relation generally we gonna use, but this is the actual relation, and what Shri has answered is perfectly correct. That look, 0 degree is what? Is it a triple point or it is a melting point? 0 degree Celsius is melting point of what? Now melting point, we know it's solid converting into liquid. Correct? Or we can also say it could be reverse freezing, so liquid converting into solid. But the case is 0 degree Celsius means only two state coexist. So 0 degree and triple point can't be same, can't have same temperature. Because I said triple point is a point where all three states exist together. So triple point and 0 degree or melting point must have some difference. That's why 273.15, because what is the triple point temperature? And what value I'm giving, guys, this is from NCERT. Okay, this value up to decimal place is given in NCERT. That's why I'm mentioning here. 273.16, this is a triple point temperature. So I can't take this constant as 273.16. In that case, our melting point and triple point temperature on Celsius scale will become same. Is this point clear to all of you? Yes or no? Are we clear with this point, what I said, everyone? We want to differentiate between melting point and triple point. That's why the constant we are adding in Kelvin scale is 273.15, not 273.16. Clear, guys?
Yes, sir.
So the question comes, what is triple point temperature on degree Celsius scale? And what is our answer? Answer
0.01
is
degree.
0.01 degrees Celsius. This is a triple point temperature. Now, this is a very basic question, but don't you all agree if we don't discuss this point in class, we may skip it. And if directly it comes in examination hall, we might get a wrong answer because we are not sure about it, right? So these are the basic questions which we might miss. So I hope now we are clear with all the scales and their relation. So The relation between degree Celsius and Kelvin is this. Kelvin and Fahrenheit also we know. If we substitute degree Celsius in terms of Fahrenheit, we'll get the Kelvin and Fahrenheit scale. Okay, so we have, I think, 5 minutes. Let me take few more questions, and I'll give some questions in the group also for you guys to practice. So one sec. Guys, go for question number 4 and 5. Questions are visible to all of you?
Yes, sir.
Okay, so question 4 and question 5. Isabel, Shri, correct beta. Gaurangi, correct. Konika beta, please check your answer. I think some calculation mistake is there.
So, what do we mean by centigrade mercury scale?
Beta, that is unknown scale unit.
Okay.
Abhijay, correct. Arinjay, correct. Aditya, correct. Himanshu, correct beta. Yash, check your answer. Isabel, Shri, correct for second answer also. Very good. Aditya, correct beta. First one, guys, they are saying that it has changed by 40 degrees Celsius, but you are having a thermometer of Fahrenheit and initial temperature is 68.2. What will be the final temperature? So simply we know that delta T in Fahrenheit is 9/5 times delta T in degrees Celsius. Now, first of all, into 40, I think. So this will be 72 and final temperature minus initial, and initial is how much? 68.2. So your final temperature will be 72 plus 68.2. Clear? So this is what we got in the first place. Fifth one, steam point and ice point of a mercury thermometer. You can take it as unknown thermometer, right? Aditya, correct beta? So 80 and 20, what will be the temperature in centigrade mercury? With thermometer reads 32 degree. So basically, degrees Celsius, you have to, Mercury scale means Celsius scale. So here you can simply use this temperature in degrees Celsius upon 100 equals to 32 minus 20 upon 80 minus 20. Clear? All right, guys, you have another class. Tell me one thing. Are we clear with whatever we have discussed in this class? All of you?
Yes.
Yes.
Yes, sir.
All right. So we'll try to continue our discussion in the next class. Thanks for joining. Take care, everyone. Bye-bye.
Yes, sir.
Bye, sir.
Thank you,
Thanks.
sir. Bye.